Hello, so today we continue with chapter 4 on forces, and this is the last piece of information that is new in the chapter, okay? And it is about when we have two objects connected together by a string. So far, all the problems we've been working with, they were one object lying on a surface, on an inclined plane, connected to a spring or a string. Okay, so today we will talk about if we have two objects connected by a string or a rope. Okay, so before I continue, I just want to remind you very quickly how to use Newton's second law. So first we draw a free body diagram, then we choose an x-axis along motion and y-axis perpendicular to the x-axis. Then I choose whether I want to use summation of fx equal ma or summation of fy is equal to 0. Okay, so now let's take this example. So it's called two body problems. I have two bodies, M1 and M2. M1 equals 3 kilogram, M2 is equal 5 kilogram. They are connected by a light string that passes over a frictionless pulley. This is just to tell me that the pulley doesn't exert any force on the object. Okay, so now let's solve the problem exactly as we used to solve all other problems. So we will start by drawing a free body diagram for each of the two objects. So let's do it. I will put this is object 1. This is object 2. Okay. They are connected by a light string. So let's take this. Actually, there is no need to draw the light string. Let's just put the forces on each of them. The first one, the forces acting on it is, of course, W1. And then since there is a rope, so there is tension 1. Okay. And then the second one, there is the weight 2 and tension 2. But now this is what I want you to know. If they tell me that the pulley is frictionless, so and this rope is inextendable, then these two, tension 1 and tension 2 is equal to 0. So instead of saying tension 1 and tension 2, I will just say tension. Okay. And this is weight 1. And this is here weight 2. And this is also just tension. Okay. No other forces. So these are the two forces acting on the two objects. So this is M1 over here. And this is M2 over here. Okay, so we drew the free body diagram. Now we have to draw the x-axis and the y-axis. So let's see how the objects will move. So this is 5 kilogram, this is a 3 kilogram. So how will the objects move? This will move upward and this will move downward. So for the first object, the x-axis will be upward. And for the second object, the x-axis will be downward. Okay. So here is x-axis for the first one. And here is x-axis for the second one. So we just deal with them as two separate objects. Okay, so now draw a free body diagram for each of the two objects. I did it. Now determine the acceleration of each object. So these two objects are moving with the same acceleration because they are connected to the same spring. Once M2 start moving, M1 will move with the same acceleration. So the acceleration is acceleration 1 and acceleration 2 are the same. Or we say acceleration 1 equal acceleration 2. So we will call it simply acceleration. So in order to do it, we have to apply Newton's second law on each of them, okay? And since we need acceleration, so we have to apply the first one of summation second law, Newton's second law, summation of fx. So let's start. Let's start with summation of f1x is equal to m1a. Okay. That is tx, t1x, or just we can just call it tx. Here we can come and put what are the x and y components. This is all of t in the plus sign, and then it has no y component. It's all on the x-axis. W1, it's all on the x-axis, but we have to pay attention that it's minus 0. This t is also all on the x-axis, but it's in the opposite direction of the x-axis. And W2 is with the x-axis, so it's all of W2 plus. Okay, so now we come back here. Tx plus W1x is equal to M1a. And now Tx is T minus W1 is equal to M1a. So T is equal to M1a plus W1 is M1g. So T, this is T. Okay, this is from the summation of f1x equal to M1a. Now we do the same, but summation. Notice that in this equation, T equal M1a plus M1g, I have two unknowns. So T is an unknown and A is an unknown. And in order to solve it, I need another equation, and then I can do two equations in two unknowns. Okay, and this is why I will be doing summation of f2x is equal m2a. And let's see what we get. We get tx plus w2x is equal to m2a. Tx is minus t. It's here because it's in the negative, in the opposite direction of the x-axis, plus w2 because it's along the x-axis, equal to m2a minus t is equal to m2a minus w2, which is m2g. Okay, now you see this tension, it's m1a plus m1g. So instead of tension here, I will put m1a plus m1g. This is equal to m2a minus m2g. Now I can facilitate my life. Minus m1a minus m1g, which is 30, equal to m2a minus m2g, which is 50. Okay, and now if I take m1a to the other side, it will be m2a minus m1, sorry. If I take m2a to the other side, I will have minus m1a minus m2a is equal to 50 minus 50 plus 30. Okay. Okay. Instead of m1, I will put its value 3. So minus 3a minus 5a is equal minus 50 plus 30. minus 3a minus 5a is minus 8a, right? Minus 8a is minus 50 plus 30. This is minus 20, implies a is equal to 20 over 8 equal 2.5 meter per second square. Okay, so we got the acceleration. Now the question is to get the tension. I will just go to this equation over here. This equation over here, which is tension is equal to M1A plus M1G. So tension is equal, M1 is 3 times 2.5 plus 3 times 10, which is 30. So we get tension is equal 37.5 Newton. Okay, so this is, we solved it using two equations in two unknowns. Luckily, and problems where we have two objects, we can use something called the system approach. So here is the solution in two equations to unknown. Now, two body problems can be solved using the system approach. This happens if the two bodies are connected by a string so that the bodies have a common acceleration. That is, they are both moving with a common acceleration. Then it's possible to use the system approach to calculate the acceleration. Newton's second law for the system approach is summation of F external equal M1 plus M2 times the acceleration, okay? Where F external are the external forces. Tension is not an external force, it's an internal force because there is this rope connecting the two objects. So the tension is an internal force because it's along the rope from both dimensions. Let's see how can we solve the previous problem using the system approach. So the system approach, I've put it over here. We use this formula, summation of F external is equal to M1 plus M2 times acceleration. So let's see how we apply it. We start by the norm, the usual thing, we draw. So we start with the usual thing, we draw. The very first thing is draw free body diagram for each object. So I do exactly the same thing as the previous exercise. Then I choose x-axis and if necessary y-axis. Over here I don't need y-axis. This object is going up, this object is going down. So here the x-axis is upward, here the x-axis is downward. Then what are the external forces? Then I look at my forces. Which forces are external? I already told you that tension force are not external, they are internal. So the external forces are W1 and W2. Okay. Now I apply the formula summation of F net, or sorry, you can say summation of F net or summation of F external equal M1 plus M2A. Now what are they? They are W1 and W2. I look at the first object, for example. W1 is opposite to the x-axis, so it is minus W1. W2 is with the positive x-axis, so it's plus W2. So W2 minus W1 is equal to M1 plus M2 times the acceleration. Acceleration is equal M2G minus M1G over M1 plus M2. M2G is 50, M1G is 30. And we get acceleration equal 2.5 meter per second square. So notice how easier this approach is. We just have to be careful what are the external forces and their direction. So if W1, if you put plus instead of minus, you will get an error here. You will get the wrong answer. Now we need to find the tension. Tension is an internal force. So I cannot use this formula to get tension. To get tension, I must apply Newton's second law on only one of the two objects. You can choose to apply it on the first one or on the second one. Over here, I applied it on M1. So I have M1. I have summation of F1x equal to M1A. Now I'm just applying Newton's second law on M1. So I have T minus W1 equal M1A. So T is equal M1A plus M1G. This is 3, M1 is 3 times 2.5 plus 3 times 10, and thus I got tension is equal 37.5 Newton. Okay, so the system approach helps me get the acceleration easily, but then for the tension, I have to apply Newton's second law on one of the objects. I did not call this T1, T2 because they are both the same, so I called them T. I did not say A1, A2 because they move with the same acceleration, so it's A, okay? So A1 equal A2 equal A, T1 equal T2 equal T, okay? Oh, I use this using this problem. Let's solve another exercise. An object of mass M1 is the rest 5 kilogram is resting on a frictionless horizontal table and is connected to a cable that passes over a pulley and is fastened to a hanging object of mass M2 equal 10 kilogram. Okay, so I will solve it with you using the system approach, but you can also find the two equations. So here is the system approach, we'll do it together, and here is using two equations in two unknowns. So let's do it together using the system approach. So let's solve this problem using the system approach. So we will start by drawing a free body diagram. So here we have a surface for M1. So there is a surface, okay, and there is this pulley. There is this pulley over here. So now this is my first object, and this is my second object, and they are connected by string. Okay, let's draw. So let's draw now we draw the surface and the objects. Now we draw the forces. So for the first one, we have the weight, we have the normal, we have the tension. For the second one, we have the tension, and we have the weight. Okay, so this is here. And W1, tension 1, which is T. And here I have tension 2, which is T. And W2, which is W. Then I choose x-axis and y-axis. M1 is 5 kilogram, M2 is 10 kilograms. So the system is going downwards. So this object is going this way. So the x-axis for it is in this way. And this object 2 is moving downward. So this is here the x-axis, and this is here the x-axis. It's a long motion. Okay, now we are ready. Let's put the x component and y component for each force. N only has y component, so it is 0, n. W1 only has y component, so it is 0 minus W1. Here we are assuming the y-axis will be upward. Tension here, it's T positive 0. It's on the x-axis. Tension here, it's minus T 0 because it's in the opposite direction of the x-axis. And W2 is positive W2 0. Okay, so we come here and we apply. We need to calculate the acceleration. So summation. So what are the external forces? So summation of external forces equal M1 plus M2A. What are the external forces? Well, external forces are, what are external forces along motion? Okay, they should be external forces along motion. So this object is moving on the x-axis. Are there any external forces along the x-axis? No, there is tension, which is internal. The other one, the tension is internal, and the only external force is, so the external force is W2 only. Okay, and now I apply, so I have W2 is equal to M1 plus M2 times acceleration, M2G equal M1 plus M2 times acceleration. So acceleration is equal M2G divided by M1 plus M2. What is M2G? It's 10 times 10, so it's 100 divided by 10 plus 5, so it's 15. And this gives me acceleration is equal to 6.67 meter per second square. Now to find, this is part B, to find part C, to find the tension in the cable. That's here, need more space. Find the tension in the cable. Apply Newton's second law on one object only. In the solution, I did it on object 1, but here I can do it on object 2. So choose object 2, for example. Summation of Fx of F2x is equal M2A. What are the forces acting on the second object? So this is the first object, M1. This is M2 here. What are the forces acting on it? They are, and the x component, so this is Tx plus W2x equal to M2A. Tx is minus T, W2x is W2 equal to M2A. So tension is equal, or minus tension, it's okay, plus M2G. So 10 times 10 is equal to M2, which is 10 times 6.67. So I get minus T is equal 10 times 6.67 is 66.7 minus 100. So I get minus T is equal to minus 33.33, which means T is equal to 33.33 Newton. Okay, so I use the system approach in order to get the acceleration and the tension. Notice it's in these problems, when they ask for the acceleration, it's easier to get using the using the system approach. But if it also needs the tension, so first I have to get the acceleration, then the tension. Okay, but for the tension, it will take me, I have to work on only one object. So, so over here, you will find the solution using system approach. And over here, you will find the solution using two equations and two unknowns. I advise you not to look at the solution, to hide it and to do it on your own in order to see if you understood the concept or not. This is all for today. If you have any questions regarding this lecture or any other previous lectures, just send me an email and I can answer it tomorrow during the live session.